Hello, and welcome back to another episode of Food Science Friday. Today, we're diving into our first dessert and making Panna Cotta. Happy Friday! Panna Cotta means cooked cream in Italian, and it's got this beautiful, smooth, silky texture. It's made with whipping cream, milk, and gelatin. So it's got this awesome texture and can be flavored with a variety of different things. So you're always going to want to start by heating 2 cups of cream, 1 cup of milk, and whatever you're going to use to flavor it. So I'm, for example, going to use a little bit of vanilla. So that's a more kind of traditional panna cotta recipe uses vanilla. And I'm going to let that infuse over medium heat. But I'm also going to make another version with an Earl Grey tea. So it'll be Earl Grey Panna Cotta, which I know is a little bit of a British take, a British fusion with an Italian dish. And we'll see how those both turn out. Now, there are 3 phases of gelatin formation. But before we apply heat, we've got to bloom the gelatin. So let's get blooming. In order to bloom or hydrate your gelatin, you're going to take 2 teaspoons of whatever unflavored gelatin you happen to have and add it to your cool or room temperature cream that's been infused with whatever flavor your final panna cotta will be. Gelatin can absorb approximately 5 to 10 times its weight. Unflavored gelatin will clump if not properly hydrated in cool or room temperature water before applying heat. After waiting 3 to 5 minutes, your gelatin should be sufficiently hydrated. And now you can move on to the second phase, dispersion. So place your pan over medium heat. Stir over medium heat until the gelatin dissolves, but doesn't boil. Gelatin disperses at approximately 100 degrees Fahrenheit or 38 degrees centigrade, so it doesn't need to boil. During dispersion, the protein molecules in the gelatin will denature and unfold. So the third phase is gelation, which occurs as you cool the mixture down. So we're going to put these into these glass jars and then we'll refrigerate them for 6 hours. Upon cooling, the denatured proteins will begin to aggregate or come together. The mixture will first convert into something called a sol, a colloidal dispersion of a solid in a liquid, so basically solid particles dispersed in a liquid. Then after a few hours in the refrigerator, it will create a more solid-like gel.